Welcome. Let's have a look at day 11, Plutonian Pebbles of Advent of Code 2024. For this problem, they give us this string, and for each of these, they're really stones would have this with an engraving on them. So whenever you encounter a stone, you're supposed to apply one of these rules to them. If the stone is engraved with a 0, change it to a 1. If the stone has an even number of digits, split up the stone into two stones, where the first stone is the first half of the digits and the second stone is the second half of the digits. And lastly, if neither of those rules applies, then you multiply the digit on the stone with 2024. So looking at this string here, and they apply these rules by what they call blinks, or simply an iteration. So in this case, after one blink or one iteration, the first stone becomes a 1. 1 becomes 2024. 10, notice how 10 is even in length, so we split that up into two stones. So 1 and 0. 99 is also of even length, so we would create two new stones, one of value 9 each. And lastly, 999 does not apply to, or does not qualify for either of the other first two rules. Hence, we multiply that by 2024, and we get this here. That is the essence of the problem. There isn't much else to it. It's quite straightforward. So let's go over how I did it. So that was this S string is that first example. They also give us a follow-up example, which is here, and then they also give the actual test data, or test input, or input data. So what I do is I simply convert this string into a list, storing each of these elements as integers. I was undecided if I wanted to store them as strings or integers, because remember, at some point for this rule, we need to consider this as a string because we want to know the length of the digits, and that's best appropriated, or the best situation is if that element is a string rather than an integer. So in the end, I just decided to store each element as an integer. So let's just do as asked. So what I decided to do, let's just check it for the first one. So we'll run it one time. So this is the result, or the code that I used to find the answer during earlier, but I'll just rewrite it. So we don't really need the index. We just want to do it. We want to quote unquote blink a certain number of times. And what I decided to do is make a new list for every iteration, for every blink, just to make it easier. As a heads up, this didn't work during part 2, which is fine. So, and now we want to loop through every element of the list. So this is the number of blinks, and this is the operation we're performing. So for j in range length of L. And by the way, at the end of this loop, we'll actually just update L to be whatever M is. So at the first index, we check if L of j equals 0. If that's true, remember what we do, we change that stone to a 1. So, but we'll be applying the changes to M instead of L. So M dot append 1. Else if, so remember the next rule says we have to check the length of the string. So, sorry, the length of that element. So if we convert it to a string first, so L of j, convert that to a string. Then we find the length of it, length of that, and we say mod 2 equals 0. So if that's even, well then we want to cut it in half, make 2 new stones. So for example, if that element is something like, which is for now 20, 24, we would make two new stones. One stone would be 20, 20, and the other one would be 24. So let's do that. So what I decided to do to make it easier was to use a variable, so string of L of J. Then I found the length of it, and then I use that to add that to my list M. So M dot extend, and the new element will be, so we want to say, okay, R from the beginning to n divided by 2. But then we want to convert this to an integer. So don't forget to do that. So we do that here, int of that. And we kind of want to do the same thing for this guy. So let's kind of do it. So we just copy that. We'll modify this a little bit. So we need to now adjust this, the bounds. So we move this to the front. So now this says from the beginning to the middle for the string, and then from the middle to the end. And I think this is adequate. And then lastly, if none of these two first rules apply, we simply multiply the element by 2024. So we say m dot append that element times 2024. And then I update list to be whatever m is, and then I run this again. And we can check it. So remember, this was for this first example, they just blink one time. And we could just print our result. So we could just print the result. It doesn't matter. It's maybe L is fine. And then we want to print the length of L. Print the length of L. Because that's what ultimately what they wanted to know. Sorry if I didn't mention that earlier. They say, I'm sorry, I think I didn't. So for this example, we haven't gone over it yet, but after blinking 6 times, you have 22 stones. If you blink 25 times, you have 55,312 stones. So they say, how many stones will you have after blinking 25 times for the input data? In this case, we're just going to blink once, and we should get this, which has, what is it? 7 stones. So let's run it. What happened here? Oh, am I using the wrong one? Yeah, so sorry, we should have been using this data. My apologies. Okay, good, that's 7. So this should be exactly what we have over here, and it looks good. And we can just check this one, and we should get, after 6, we should get 22. So that's this one here. And after 6 blinks, we should get 22. Let's run it. Okay, good, we get 22. I did print the list just to get a look at it, but we didn't really need it. Okay, great. And then, so we don't need to run the actual data. So that was it for this problem. Since this was part 1, it was a little bit easier, so we could actually build the list. So as you can see, for this problem, the list was what, 200 and length of 211,306. So that's a little bit long, but most computers can handle that. However, for this second part, it was 75. That was the number of blinks or iterations. So my computer was taking too long to do this, so I went with another route. decided to use recursion and caching. So let's go over that. So what I did for this one, let's comment this out. So my idea was something like this. Every time I see 0, that's somewhat easy because I can predict what the outcome will look like. For the other numbers, I don't really know, but something like 0 or 2024, those are certain values that I can calculate quite easily. But I decided just to go with 0. So if I blink once with 0, I get 1, according to the rules. If I blink twice, I get 2024. 3 times I split it up into 20 and 24. And 4 times I split it up again because this is the length, has an even length, so 2 and 0. And this also has an even length, so I split it up into 2 and 4. So when I perform my depth first search and I see an element of 0, I actually check for the remaining depth. So initially I start with some elements. Suppose I start with 0. And I want to go, I don't know, 5 times. So what I'm allowed, when I see a 0, if the element 0, I know for sure I can reduce this. So that's what I did. So I said if there's more than 5 remaining depth, I can already jump to it. So notice how this is 0. So if I 1, 2, 3, 4. So notice here I have four follow-up recursions. This is 2, 0, 2, and 4, which is what we have here. 2, 0, 2, 4. And I can reduce the depth by 4. So in essence, making the work just less. I just have to do less recursion. I didn't probably need to do that, but I just felt natural for me to do that. So I did it. So element here, and this is the remaining depth. Okay. And once the base case, if we're not allowed to blink anymore, so this is 0, I can't go another level deep. I just return 1 because that's how many of me there are. How many elements? There's 1. And this one, if the element is 0 and the depth is 3, so the element is 0, I can go 1, 2, 3 more. So 1, 2, 3. I return 2. If I'm 0 and and the depth is 2 or 1, this is still 1 element, so I just return 1 element. I return 1. And then this is basically the same as before. If the element is not 0, we check the length of the string. And I do as before. I set r equal to the actual string. I didn't use n here, but I could have. Yeah, I don't want to do it now, but we could have. So this is, I get the front half of the string, and I subtract 1. I get the second half of the string, and I subtract 1 from the remaining depth. And lastly, if neither of these previous rules apply, then we simply multiply that element by 2024 and we go 1 depth deeper. And that's it. So what I do is I essentially run this for every element in the list. So let's see how that played out here. That was right here. So let's just take that out to the front. So what we had up here was here. So Al right now is, well, it's 125 and 17. So I say for every L, for every element in L, perform this here. So I say, okay, first send 125 into this function and run it 75 times and get a count. run 17 as for I, and run it 75 times and get a count. And for all of your counts, we add them up, we use this sum, and then we just print the result. And that's it. It was, we can calculate each of these values independently and add them up at the end, because they don't relate to each other. They don't affect each other. So again, I just simply looped through all of the elements, and I ran the function on each of them. Here's the depth, and I just summed all the results, and here is the answer. Let's run it on maybe this, yeah, this one is fine. So for this one, well, it shouldn't matter, but, well, we already know the answer. So actually, we could run it 25 times on that. Why not? Let's run it 25 times. So 25 times on that. And hopefully we get this 55,312. So let's do that. Let's go here. Let's maybe minimize it a little bit. And run that. And don't. That's fine. Okay, great. So we got this 55,312. So this one wasn't too hard. It was just a matter of using, if you don't use this caching here, it'll take a long time. In fact, I haven't run it without it. Yeah, I did try running it without it, and it took a little bit too long. Let me demonstrate that for you. Okay. Oh, interesting. Did I not save it? Oh, you know why? You know why? I think I didn't run it without the cache before. I think this helped it a lot. This depth -4. I really think it did. Oh, but I am not using. Sorry, I am not using the real input. So let's see that. Sorry. So let's try this input, which is the real authentic input. And then we need to run it 75 times. Yeah, this will take forever. Yeah, so it takes a long time. So even with the assistance of this depth -4, yeah, it doesn't help out enough. So I used this cache here. Yeah, just import it from func to the cache. Okay. Could run it now. Cancel this. Yeah, so we get the answer quicker when we cache the results. Okay. So good luck to you. If you felt this video was helpful or educational in any manner, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.